Hello students, we have already studied Rule 1, which says that incident ray parallel to the principal axis passes or appears to pass through the principal focus of the lens after refraction. Now let's see Rule 2. It says that a ray of light passing through a principal focus after refraction from a convex lens will emerge parallel to the principal axis, while a ray of light appears to meet at the principal focus of a concave lens. After refraction, it will emerge parallel to the principal axis. Isn't it just the opposite of the previous law? Yes. We stated previously that a parallel incident ray will pass through the principal focus after refraction, whereas in Rule 2, we state that an incident ray passing through principal focus will emerge parallel after refraction. As you can see, this is the incident ray. It is passing from focus and it touches the lens at this point. Yes, it is in the case of convex lens. Now, as it passes through this prism of the lens, it bends like this at this angle and now emerges out of the lens on the opposite side, becoming parallel to the principal axis. But wait, in case of a concave lens, the incident ray diverges after it refracts in the opposite direction. And thus, rays when extended back on the other side, it appears to be passing from the focus point. And this is the reason we say that an incident ray which appears to pass from focus point emerges out parallel to the principal axis after refraction. Thus, we can say that a ray passing through the principal focus of the convex lens emerges parallel to the principal axis, and a ray which appears to be passing from focus of the concave lens becomes parallel to the principal axis after refraction. So now let's continue with the Rule 3. It says that a ray of light passing through the optical center of a lens will emerge out on the other side without any deviation. Now you may be wondering why this is so. And is it true for both the lenses? Possible explanation could we give for this? Yes. To answer the second question, this is true in case of both concave and convex lens. It is because the ray passing through the optical center does not deviate, as the curvature of the lens at the incident point and the exit point are exactly opposite. So the deviation at the first point is cancelled out at the other point. Okay, let's understand this. We know that we can consider the structure of lens made up of prism and slab like this. So when light falls on the optical center, it is actually incident on the slab. Yes, we can visualize this like this, that light is falling on the slab. And we know that refraction at this interface of the slab cancels out the refraction at the opposite interface. So what happens is they cancel out each other and the direction of the incident ray and the emergent ray are same. However, the rays are parallel because the light ray shifts from the path. They are not overlapping each other. And this distance between them is known as lateral shift. Well, this same happens for the lens. So this portion of the lens which is made up of slab, the deviation at the first point is cancelled at the other point. But we need to note one very important point here, that for thin lens, the ray appears to be passing straight. That is, they overlap each other. Yes, the incident ray and refracted ray, they overlap each other and appear as if they are not deviating or not bending. We can also say that there is no measurable lateral shift, or it is almost equal to zero, and so rays appear straight. they do not deviate, as if it is not deviating or bending, and we say that it passes undeviated. But this is not true for thick lenses. In thick lens, there will be the measurable lateral shift. That is, incident ray will be parallel to the emergent ray, but it will be displaced, and this distance can be measured, which is equal to the lateral shift. Remember, when using ray diagrams to represent image formation, always consider at least two rays from all three. This is because we learned earlier that for an image formation, the intersection or focusing of at least two rays is required from that particular point. So what we have seen are three rules for making ray diagrams. Rule 1, which states that a ray of light from the object parallel to the principal axis after refraction passes from the focus point of the lens. Rule 2 says that if the light is passing from the focus point or appears to pass from focus point, after refraction it emerges out as being parallel to the principal axis. And Rule 3, which says that ray of light passing through the optical center of the lens will emerge without any deviation. And how do these lenses form an image? We will see it in our next video.